me share my screen. We will discuss one by one. Okay. Are you able to see the screen?
Yes, sir.
Yeah. So I'm problem. A circle of 50 mm diameter rolls along a straight line without slipping. Draw the curve traced out by a point P on the circumference for one complete revolution of a circle. Name the curve. Draw tangent and normal to the curve at any point on the curve. Okay, let me first show you how it will be looking like. Okay, now this is the actually the cycloidal curve. Okay, this is the cycloidal curve. It is something like parabola or hyperbola, right? It is not closed one. It is having some path. Okay, so to draw this one, what we need is some data required. Okay, and we need to generate 1, 2, 3, 4, 5, 6, 7, so many other generating points to join with freehand, right? So this is the curve. Then I will tell you step by step procedure how to draw this one. Okay. Now, uh, the introduction of this particular topic is if you take a cycle wheel, it is rolling on a straight ground. Okay. What happens if you take any fixed point on the cycle wheel? The point will move from place to place, right? During different intervals of time. The path traced by that point, fixed point of the cycle wheel or circle, we call that the curve. We call it as a cycloid, simple cycloid. Okay, the path is straight ground. Okay, I think I have given you some introduction regarding this, right? Have I given any introduction? Cycloids.
No, I think so.
No, sir. Yesterday,
Okay.
only rectangular hyperbola up to the tutor.
Okay. Anyway, I will show you what is this cycloid, epicycloid, hypocycloid, and all. Let me show you one more video before that. Uh, yeah, are you able to see the screen?
Yes, sir.
Yeah. So here you see cycloidal curve will be like this. Suppose a circle or cycle wheel is rolling without slipping on a straight ground. Okay. Suppose this red point, which is common point for circle as well as to the ground, right? Suppose the cycle wheel is rolling. Okay, from left to right, it is rolling, something like this. Okay, traveling. It is traveling on a straight horizontal ground. What happens to this red point while it is moving? While it is rolling without slipping. Understand? It is rolling without any slip. Okay. Now tell me what happens. This point, it is moving. It comes to here. It come here. It comes to this place. It comes to that place. Okay. It changes its position. If it is rolling for one complete revolution, that is the if it is traveling a circumference 2 pi r, what happens? That means one complete rotation. If it is taking place, what happens to this point? It is also traveling a distance of 2 pi r. Okay, so this path I call it as cycloid. Is it clear? Can you give me some? Is it clear?
Yes, sir. It's clear.
So
Yes, sir, it is clear, sir.
yeah, this red point initially touching the ground. Okay, while it is rolling. Okay, and traveling a distance of 2 pi r. That means one complete revolution. This point this red point I am showing. Okay, it is making some path. Okay. So to draw this curve, I need to generate so many points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like that. Then only you can able to draw a smooth curve passing through all these points. So that's why uh, it is important to know to generate so many number of parts. Okay. Then anyway, these cycloids, these curves, we can see mechanical gears. Okay, so many applications are there. You can also watch here. Uh, these are the teeth of a mechanical gear. The teeth, this is one teeth, second teeth. So many other teeth are there. Okay, if you see the profile carefully, uh, if you zoom the profile, the shape, you will find a cycloidal uh, curved shape. Okay, so there are so many other applications. So here this is called cycloid. Similarly, we will find a epicycloid, okay, hypocycloid also. Those things I will explain a little later. Now you can see isochronous pendulum. Pendulum is oscillating, right, from two extremes, right? One extreme here, if it is moving towards other side. So if you carefully the particular string, okay, it will have a path of cycloidal curve. Okay, so isochronous pendulum, okay, mechanical gears, like that you can find so many other applications.
Sir,
And
cycloid is a semicircular, sir.
no, it is, seems to be semicircle, but whenever I say curve means you don't have any fixed radius. When you say circle or semicircle, it is having fixed radius. Okay.
Okay, sir.
For example, cycloid, I am taking a initially one circle, right? This particular circle is having fixed radius, but the curve I have generated, it is not a fixed radius. It is having different radius at different uh,
Point.
points, and that's why curve is having normal and tangent. Okay, at any different points. So
Okay.
curve, it doesn't have any fixed radius. Okay, it is looking like this. Okay, even though if you can observe, in case of parabola, hyperbola, those are curves, those are not circular arcs. Okay, remember the difference between circular arc or circle and these curves. Okay, curve is entirely. So these engineering curves are used in engineering applications to manufacture, okay, mechanical gears, okay, so many other uh, like so many other applications are also there. I will show you. Okay, so in this class we will confine to how to draw cycloid. Okay, we will discuss remaining applications in the next class in detail. So we are in the unit number 1. So we are drawing uh, cycloid, right? So generally in the exams, you will be given problem like this. A circle 50 mm diameter rolls along a straight line without slipping. Draw the curve traced out by a point P on the circumference, okay, for one complete revolution. Okay, simple data. And draw normal and tangent to the curve. So generally for any curve at various points, you will have a normal and tangent. Okay, you can draw a number of normals and number of tangents, okay, on the curve. So at a distance of 40 mm from the straight line. So this is the problem. Okay, so immediately you just note down the data. Circle rolls on the straight line for one complete revolution. So it didn't mention anywhere a cycloid, right? So you need to understand the problem is straight line. Sorry, cycloid. So take the diameter as 50 mm. Draw one circle. If you are ready with the mini drafter instruments, you can draw along with me. Okay. Take the radius 25 with compass. Don't take 50 mm with compass. Okay. It is radius 25. That means in the problem it is given 50 mm diameter. You take radius 25. Okay. And draw one circle. Divide this circle into 8 parts. Here it is 8 parts. Okay. You can also take 12 parts also. So how to divide 8 parts? Any idea?
4 diameters, sir. 4
360.
diameters from 4 different parts.
Yeah, 360 divided by, suppose you want to divide into 8 parts, 360 by 8, 45 degrees, right? Take your protractor, mark 45 degrees, okay? Initially you draw 4 lines, perpendicular lines, okay? And the remaining 4 parts automatically, if you set protractor 45 degrees, you can able to do like this. Okay, if you want to divide 12 parts, 360 by 12, 30 degrees. Set 30 degrees, 30 degrees, 30 degrees, like, and thereafter, why we are taking all these number of parts means, suppose at uh, at particular time the point capital P, okay, is moving, right, from for one revolution this point P is moving at different intervals of time. Okay, so for convenience we are taking the intervals 1 2 3 4 5 6 7 8 intervals. Okay, so at 8 different intervals it is occupying a different place. We call that point as one generation point. Like that, we need to generate 8 points to draw the curve. Okay. Now, let me take next step. This is the next step. What you have to do? This length, one revolution is how much length? What we discussed earlier. One revolution, circumference of
Perimeter.
the, yeah, circumference of
Circumference.
the circle. Uh, it is pi d or 2 pi r. Calculate, which is equal to 1.157.14. You can neglect 0.14 because it is less value. You can take 157. Okay. If this is more value, you can round it up to 158. Okay. So take 157, draw one horizontal ground. This is actually the ground path. Okay. Straight path on which this particular roller is rolling without slipping. Okay. This is the starting point we are focusing on. So this point which is fixed to the cycle wheel or circle. Imagine this point P is fixed to the circle, not fixed to the ground. Okay. So initially it is common point for the ground as well as to the cycle wheel. Now it is starting rolling in the clockwise direction. Okay. In the clockwise direction. Now we have divided the circle 8 parts. Now this PP length, this horizontal length also, we need to divide into equal same number of parts as we have divided the circle. Here 8 parts we have done, right? So this angular line also we have to take 8 parts. So we are going to divide this pi d length into 8 equal parts.
Sir,
So
equal together, sir.
yeah, on this angular line, I am repeating again. This angle can be any angle, 0 to 90 degrees, any angle you can take. This length also any length you can take, but while cutting the arcs, you can set one fixed radius, any radius, but set one fixed radius. From point P, you draw one arc, and from that arc, you draw one more arc, like that. The distance between any two arcs must be same. Okay. How many arcs I need to draw on this line? One,
Sir,
two, three. Yeah, please tell me.
those circles we have to draw with HB pencil, right, sir?
Yeah, those things I will tell you later at the end of the problem. Okay. And after drawing all these arcs, join the last arc to the end of the line pi d. Okay. And remember, except this cycloidal curve, all other lines must be 2H pencil only. Okay, all other lines must be 2H pencil only, except cycloidal curve. Cycloid curve must be drawn with HB pencil. Okay.
Sir, if we take the circle into 12 parts, then we need to draw 12 arcs, na sir?
Yes, 12 arcs. Okay, 12 arcs. Okay, same. How to take. So I am explaining with the 8 parts. Is it clear? Okay.
Yes, sir.
Yeah. Then I am taking only 8 parts. 8 arcs I have drawn. Last arc, what I have to do? Last arc where I have to join? Last arc I have to join to the other end of the line. Other end of the line. Pi d length. Okay. So I got one line here. So match mini drafter scale to this line. Uh, Tight the knob, mini drafter knob. Move the drafter parallel to this particular line. Parallel to this particular line from various arcs we are already drawn. Okay. Now you will get like this. Okay. Now you can verify the distance between there are 8 equal parts. The pi d length is divided into this straight line. Pi d is divided into 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. Even if you measure with the scale, the distance must be same. The
Sir,
distance will be same. Yeah.
sir, how do we know where to draw that other circle, sir?
Yeah. Actually, this is not required. Okay. This circle, other circle may not required for understanding purpose. I am showing you one more circle here. That is the circle initially here. It is traveling to other side here for one complete
Okay.
revolution. You need not draw the circle. This is not required. Okay.
Okay, sir.
Then the next important step is, so you need to name all these parts P 1, 2, 3, 4, 5, 6, 7. Again P. Okay. This is the starting point of the curve. This is the end point of the curve. Now the next important step is draw horizontal lines like this. Line passing through 1, 7, one common line. Okay. Line passing through 2, 6. 2, 6 line is also passing through the center of the circle. So it is a special line. Okay. And 3, 5 common line you have to draw one line, and passing through 4 you draw one horizontal line. Okay. Thereafter draw perpendiculars like this. 1. Okay. From 1 you draw one perpendicular up to the center of the center line of the circle. From 2 you draw one perpendicular. From 3 perpendicular. From 4 perpendicular, like that. Okay. Now name the center as C naught. Okay. And first perpendicular you call it as C1, C2, C3, C4, and so on. That is also important. Okay. This is the original circle center C0. First perpendicular 1 to C1, 2 to C2. Okay. You can draw up to center line only. You need not extend those lines perpendiculars. Okay. Beyond the center line. So stop at center line 3 to C3, 4 to C4, 5 to C5. You drop all perpendiculars, name it as C0, C1, C2, C3, and so on. Almost the problem is over. The next important step is, can you guess what is the next important step? Maybe it is difficult for you to guess. Take your compass. C1 is the first center. C1 is the first center. Okay, radius is always 25. Circle radius 25. So radius is always same 25, but set the first center of your compass is C1. Okay, and cut the first line passing through 1 and 7. Okay, somewhere here I will show you somewhere.
And the radius should be 25, sir.
Yeah, radius always 25.
Okay, sir.
The first center is C1. Cut the first line passing through 1 7. Okay, so I am showing you here. I think it is visible to you, right? One arc here. Okay, C1 as my center, 25 radius. I am cutting the 1 7 line here. So this is my first generated point. If you keep on doing uh, the same procedure, you can able to get the different points. Now move your compass to center C2. Again, radius is 25 only. Cut the second line. Second line passing through 2 and 6. The center line itself, okay? You cut it somewhere, you will get this is the second arc and that is the second generated point. Can you proceed with the same procedure? Do you find any difficulty here?
Sir, one doubt, sir.
Yeah.
Why can't we cut the arc passing through 7 and 1, sir, from C2?
Yeah, see here, the center C1 is corresponding to this line 1, C2 to line 2, C3 correspond to line 3, C4 correspond to line 4, C5 again correspond to line 5, which is common to 3 5 line, okay, like that. So it is going in a symmetric fashion, right? It's not a unsymmetric curve, it is a symmetric curve. So it travels in a manner such a way that so it changes its centers from C0 to C1, C1 to C2. So earlier I have shown you one circle, right? It is traveling from left to right. That means initially the center, okay, initially the point here, capital P here, next it comes to here, and the capital P goes here, and the capital P goes here. Then it is moving, okay. Finally, for one rotation or revolution, it comes to its original position after traveling a distance of pi d. So there is a sequence, okay? There is no other logic behind. Am I clear?
Yes, sir. And from C8 should be the last arc, right, sir?
See?
At C8, from C8 we have to cut the last arc.
No. C8, it is given extra. C8,
Okay.
you don't take C8, okay?
Last is C7.
C7. C7,
Okay.
if you take the compass here, C7, you cut this red point I am showing you here, small arc here, okay?
Yes, sir.
From C7, if you cut the seventh line is where? Again, a line common to 1 and 7 only, okay?
Yes, sir.
So this is the last arc. So this is anyway, the circle comes to, the point comes to its original position here, okay? And P and P is the straight path on which the circle is rolling without slipping, and these are the points are the various positions of the capital P, which is fixed to the wheel, initially, and it is
Sir,
moving
can you tell cutting an arc from 1 to 7?
1 to
7.
actually 1 to 1 only. You have to say 1 to 1, 2 to 2, like that you have to think, okay? So first C1, if you take your compass at C1, cut the first line. First line means line 1 and 7, okay? So cut somewhere here, like that. So if you are having instruments, then you can easily practice. Now because it is symmetric curve, this is the midpoint, right? It started here, it has come to here. After that, again, don't cut left hand side. The remaining arcs you have to cut right hand side, so that half of the curve is symmetric about this particular center line. It is a mirror image, okay, almost mirror image you will get at the end of the curve. Now you take your HB pencil, join with a smooth curve, passing through all these points, okay, like this, okay.
Sir,
If you
even the circle we have to draw with 2H pencils.
yeah, 2H is sufficient, okay. Don't go for HB pencil, okay. HB, we are interested in only this curve, okay,
Okay,
cycloidal
sir.
curve. Circles, if you are interested, you can draw second circle also. Okay.
So the
Otherwise,
whole thing should be HB pencil, 2H pencil, and only the cycloidal curve should be HB.
HB, correct, correct.
Yes,
Okay.
sir.
And coming to the letters and numbers, okay. Letters like C1, C2, these letters, radius R, capital R. So these numbers and letters, you can use HB pencil, dark pencil. Okay. Remaining all other lines must be 2H pencil only. Now we are left with normal and
Sir,
tangent.
can you repeat again the mark readings with the numbering with?
Numbers means 1, 2, 3 letters. Okay.
Yes, sir.
Numericals. Okay. Alphabets and the dimension values 157. So
Yes,
these must be HB dark. So somebody can read, right? So
yes, sir.
those must be to HB. Apart from that, so line division method here, drawing parallel lines, drawing perpendicular lines, horizontal lines 1, 7. Okay, passing through so many lines we have got, right. Those are not necessary to show with HB pencil. You can use 2H pencil. Okay. Uh, this particular curve must be highlighted. Okay. Yeah, someone please mute yourself. Some disturbance is coming. Yeah. Now we are left with normal and tangent. Now in the problem it is mentioned that from the ground it is 40 mm distance. So to PP line is the ground. You take 40 mm distance above the ground, draw one horizontal line. You can able to show the point as the point on the curve somewhere here. Okay. Now here you see the right hand side. You see this is the 40 mm height with the mini drop this horizontal height 40 and draw one horizontal line onto the curve. So you can locate this point as Q. This is the given point at a distance of 40 mm on the cycloidal curve. So at that point we need to draw normal and tangent. Sometimes they don't mention the height at anywhere on the cycloidal curve. Draw normal and tangent. Simply they will give like that. Okay. So here it is specifically mentioned 40 mm height. So you draw 140 mm height horizontal line that will meet the cycloid somewhere. That is the given point Q. Now how to draw normal and tangent at that point? Okay, that is our question. Now you again at this point Q set the radius 25 again, circle radius. Okay, cut the center line. Cut the center line. Here, which is the center line?
Passing from 2.
2 6,
D
sir.
not to C8, sir.
2 6 line. Okay, center line means line passing through 2 and 6 horizontal line where we have marked all centers, right? C1, C2, C3. So this is the center line I am asking. Okay, now with your compass set radius 25, cut that center line. Cut that center line somewhere here. You will get somewhere here. Take radius is how much? Radius 25 only. Circle radius. This is the arc you would get here. Okay. From that point, drop down one vertical line onto the ground. Okay. This is the ground. PP line is the ground, right? So you would get one more point here. That point I call it as M. So join M and Q. That is the required normal or tangent.
Normal.
Normal, sir. Normal.
Normal, sir.
Very good. Okay. Now you know how to draw the tangent, right? Match your mini drafter scale, one of the scales to this line and draw one perpendicular at point Q. Or you can use protractor. Better you go by mini drafter. Okay. So this is the way you need to draw normal and tangent at anywhere on the curve. I have shown you that point here. We can take the Q point somewhere here or here. You can get the normal and tangent. So only thing is, first step important, take radius 25, cut the center line. Center line. Okay. Take the center line. So from that point, I have to drop down one line, vertical line onto the ground. Now from that point, I am joining given point Q with a ordinary scale or drafter scale. Tight the mini drafter now. You can able to use the same drafter to draw this normal, tangent also. Okay. So this is the way. If you this procedure is familiar to you, then you can even apply this procedure for epicycloid. That is the next problem. Okay. You can use you can able to use the same procedure steps for constructing epicycloid, even hypocycloid. So that means if you understand clearly this problem, you can answer two more problems with small modifications. Like you remember the difference between ellipse and parabola, right? Only vertex point is changing, right? Vertex point we are shifting. Okay, there is otherwise there is no difference between ellipse, parabola, hyperbola for construction of the curves. Okay. Similarly, if you understand this procedure, you can on your own you can able to make up the epicycloid and hypocycloid. Now we can ask few questions. Then we will move on to epicycloid. I will explain. Then we will conclude the section. Okay, session. Yeah. Any other questions?
Sir, in the question they will give the device.
Yeah, some voice is breaking.
In the question they will give the d value, sir. Here you pi d is equal to 157.14 you take now.
Okay, so listen carefully. This we need to calculate. Nobody will give you. Okay, the diameter initially given 25 or 50 diameter is given, right? For one revolution, pi d is the formula. You need to calculate. Okay, only the diameter will be given in the problem. Any other questions?
No, sir.
Not able to hear you. Yeah, yeah. Correct. Okay. Yeah, very simple. You take one radius 25 circle, divide it into 8 parts by taking 45 degrees. Since the circle is rolling clockwise, give the numbers in anti-clockwise manner 1, 2, 3, 4 in anti manner. Okay. Uh, give the first point as P. Here you start at 1, 1, 2, 3 like this. Okay. And similarly, take the pi d length, horizontal length pi d, divide it into same. Here 8 parts we have done. Here also you need to draw 8 arcs to divide this PP line into 8 equal parts. Thereafter, vertical lines perpendiculars from 1 to 3 to mark C1, C2, C3 on the center line. And thereafter you draw. Yes, please. Yeah, I said already. I said you can even draw this if you are interested. Otherwise, neglect it. Okay. There is no. Only thing is, if the circle is initially here, finally it is coming here. Now you decide it is required or not. Okay. Thereafter, passing through 1 and 7, draw horizontal lines 2, 6, 3, 5, 4. Then it's the last step, important step, using your compass. Take your compass, set the radius C1, radius 25, center C1, cut the first line. Okay, line passing through 1 and 7. Similarly, center C2, cut the second line, line passing through 2, 6. somewhere here. Similarly, C3 center, cut the third line somewhere here. C4 center, cut the fourth line here, like that. You would get a smooth curve passing through all these. Anyway, if you have drafter instruments, you can able to make up these things. There is no difficulty in this particular problem. Okay, just you make practice. Normal and tangent also, you can choose 40 mm height. You take any point Q. That Q point must be 40 mm height from the ground. Now take your compass, set radius 25, cut the center line. From that center, you would get one point here. Drop down one line vertically onto the ground. Thereafter, you join this point M and Q. That is the required normal. And draw one more tangent to that normal from point Q. Okay. From point Q only, you need to drop one perpendicular. It is tangentially touching the curve. Okay, like this. The tangent should never come inside the curve. Okay, only the normal pass inside the curve. Okay, so this is the way we need to draw on the drawing sheets. Okay, now epicycloid also same steps I said, right? So today I would like to stop here because we are having less time. How much time is there?
12 minutes.
12 minutes.
Yeah, I will try to give you some brief introduction of epicycloid. If you can able to draw on your own, you can draw. Otherwise, we will continue in the next class. So again, I am showing you my screen. Okay, I will show you one more screen. Epicycloid. Okay. Yeah. So earlier, I will ask you simple questions. In the previous problem, the rolling circle is rolling on a straight path, right? On horizontal ground. Okay. What happens if that horizontal ground becomes circular path, circular ground? What happens? Imagine circle is rolling, but not on the horizontal path. Circular path, if it is, imagine that the ground becomes circular path. What happens? Are you able to imagine any difficulty? Can you guess what happens? It is looking
Sir,
like
it doesn't roll.
it doesn't roll. Okay, let me show you. So once again we will discuss later. Now here T2 you are finding one curve, right? Circular arc here. I am showing you. This is the circular path on which above that circular path cycle wheel is rolling like this. So it can roll. Okay, it can roll. Instead of straight path, circular path is there now. This is if you take any point which is fixed to the wheel. Okay, now if you trace the path, it is taking place while it is traveling for one complete revolution. Then we will get a epicycloid curve. Okay, something I will show you. Are you able to see that curve?
Yes, sir.
Now, only the difference is earlier passing through 1 and 7, we drawn horizontal lines, right? Do you remember? Passing through 2, 6 horizontal line, 3, 5, 1 horizontal line, right? In case of cycloid. Do you remember?
Yes, sir.
Yes, sir.
Now,
Yes, sir.
yeah, what is happening to this 1 7 line now? Straight line becomes
Circular one.
circular arc. Okay. So 2 6 also circular arc. 3 5 also we got one circular arc. Don't worry, I will tell you what is the radius of that circular arc. Everything I will explain in the next class. So you need to compare and do the you need to do some analysis. What is the difference between epicycloid and cycloid? Earlier, if you remember, we don't find any angle right here. Here we are calculated some angle here, included angle. But in case of cycloid, there is no simply it is rectangular box. Okay, there is no angle calculation, but here we need to calculate one angle. Here the ground, horizontal ground PP line. Earlier it is horizontal. Now it is having some radius. It is having some radius. Here angle we have divided 8 parts. There horizontal PP pi d we have divided 8 parts. But in case of epicycloid we have calculated some angle, included angle. Because the straight path becomes curved path, right? So we got some angle, included angle. We have divided 8 parts. Circle also we have divided 8 parts. Rest of the procedure is same. Rest of the procedure is same. Instead of drawing horizontal lines, we are drawing circular arcs. Okay. Here 2 6 arc we are getting here, right? And we will get one more center arc also separately. A small gap is there. C naught, okay, C naught and O. If you take the radius C naught O to C naught, you would get one circular arc. That is the center arc. On the center arc, you need to mark C naught, C1, C2, C3. Okay, but if you take O2 as radius, passing through 2 6, if you draw one arc, that is not meeting with the center arc. Center arc and arc 2 6 slightly having small gap. That is also one of the difference between uh, uh, cycloid and epicycloid. In the case of cycloid, what happens? Center line and 2 6 line also same. There is no gap between those two lines. But here you would get one more arc passing through C naught with the O C naught as radius. Okay. So instead of horizontal lines, we are getting here in case of epicycloid circular arcs. Okay. Uh, so how to calculate these angles, everything I will explain. Don't worry. Okay. Simple formula that I will explain. Now coming to uh, hypocycloid, I will show you one more screen here. Now suppose with this circle or cycle wheel rolling inside that curved path, okay, there is a ground, curved path ground is there. If it is rolling inside, okay, that point capital P takes different positions like this. Okay, so this is the rolling circle. It is rolling in this anti-clockwise direction. So this point P, which is initially here, actually this is the ground, PP. This is the ground, PP ground. Now it is rolling inside. Have you went to anywhere like circus in your childhood? Circus, where a big globe is there inside a rider. Bike rider is riding inside the globe. Have you seen such a?
Yes, sir.
Yes, sir. Yes, sir.
Very good. Now imagine uh, this ground is in the shape of globe. Okay, inside that globe, this is the bike. Suppose if you take a two-wheeler, suppose if you take this is the one of the wheels. Two wheels are there, right? For two-wheeler, one wheel. Okay. So imagine there is a person inside riding the bike. Okay, inside the globe. Now, if you focus on a particular wheel, which is initially touching the globe somewhere here, So while he is traveling in the anti-clockwise direction inside this entire globe, so this point P, for one rotation or one revolution, it is taking this path. So this is called hypocycloid. Can anybody remember the names? First one is cycloid. Second one is
Epicycloid.
yeah. Third one is
Hypocycloid.
Hypocycloid.
hypo inside the curved path. AP above the curved path. Okay. And cycloid, simple cycloid or cycloid on the horizontal straight path. Okay. So according to the path, the point is taking different positions and path. It traces different curves. Okay. So this is the way we need to draw. So you need to know before in advance. You need to know this is the hypocycloid so that you can easily draw while you are using instruments and all. So you will understand after getting 1 or 2 points. You will understand that the next point, the next point will come here like that. Okay. So this is the way. These are the important engineering curves we generally use in mechanical gates and other important applications. Okay. So these are curves like elliptical curve, parabolic curve, hyperbolic curve. These special curves. Okay. So these 3 curves also you need to draw on the drawing sheet. Okay. In the next class, what I will do is I will explain once again epicycloid. Hypocycloid you need to draw on your own. Okay. That will be the second assignment for you. Okay. So anyway, any theoretical questions you are having on this? Otherwise, we will conclude. If you don't have any question, then we will wind up. Anyone? Now you understood, right? Overall concept of cycloid, epicycloid, hypocycloid, right? Overall concept you understood, right? Then practicing is the next step and very important. You have to practice it along with normal and tangents. Then we will see some other topic, right?
The last two you will explain.